22, 23, you think 23?
25.
25, I'm sorry, 25. Okay, we'll go 25. We'll do this again. Change the set point to 25. And going to increase it by 5. And have it change at 5 seconds. What's the next one? The set point changed before the system ever got up to the initial set point. That is a no-no. How can we make the system get up there faster? We can't. We have to change the time at which our set point changes to get somewhere over in here. So I need to change the time of the set point change, let's say to 12. So it's fully steady before I change the set point. This is true for all of you, but it's more accentuated on flow. You suppose I knew that ahead of time?
I suppose.
So what did I say? Change this to 12?
Yeah.
We can't do that. Let's make it 30. How about that? I'll change that to 30 and change this to 15 right in the middle. That's it.
Change the set point value.
Huh?
You didn't change the set point value.
What do I want to do that? And this I want to, where is it I want to change? Right here. 30? Thank you. Y'all are sharp. Y'all are sharp today. Hey, nice, huh? Right there, right there.
It's pretty sweet.
Nice. And remember, I have the controller turned off, so nothing's going to happen when I change the set point. Shall I try another one where I turn on the controller?
I suppose.
Who said that? Nobody's saying so much. I'm going to turn on the controller. How about 0.1? That sounds like a way to start. Higher. Okay. 0.2.
Let's go to 10 again.
You want something larger, I'll do 0.2. What? That's what controllers do.
Obviously.
This stuff over here is what controllers do. The flow was at 0. The controller says, hey, I want this up at 56 in order to get, then this goes up here to, wow, it goes up here to 90. The controller says, that's too high, I'm going to go down. So they compromise eventually and steadies out here at my set point of, what was it, 25. And then when the set point changes, look, this changes a little bit. Put this in Excel and you can zoom in on this and see better what's happening. This thing automatically adjusts the y-axis over here to account for this blip here. So, glad I thought about that. This stuff over here is garbage. It's just getting ready for the experiment. Do not ever put it in your presentation. Do not ever put it in your words, ignore it. X out of that. Now, over here, this stuff is boring. So the only interesting place is right in here. So zoom in on that when you're making your graphs and whatnot. Shall I try a larger case of C? How about 0.3?
0.5.
Let's try one.
0.5?
0.5.
0.5, okay, 0.5. You know, they're so picky. Oh, there's that craziness that's garbage. The need. Pardon?
It was originally, but then it jumped even more.
All right, so it finally settled down here. I call that settling down. This is garbage. It settled down. Larger,
I see this calls for a larger gain.
0.6.
Can we try one?
I'm gonna try one. I'm gonna go for it. All right, I'm gonna go for one. By the way, if I had done my root locus on this, I would know some values. This is just called wild ass guessing right now. But if I had done my root locus, I'd have some reason to pick some numbers here. Swag.
Scientific wild ass guess.
Scientific wild ass guess. How much is this? 1?
Yep.
What do you notice about this graph over here? That's your controller operating line. Ah, it's stable
Yep.
with an offset. Same thing you saw in your proportion only body. What's that do now?
10.
Huh? 2? How about 1.75?
Too many significant figures, I'm saying.
Science too.
Oh, I might show the flow people something. I might show the flow people a trick. Shall I show you a trick?
Not if it doesn't apply the pressure also, Dr. Henry.
What's that?
Do the trick, not unless it applies the pressure also.
It doesn't apply pressure, just, okay. I would say that this garbage area almost impinges on the place where I'm interested in. So I'm going to do this experiment again and change it from 15 to 20 so that I really see it settle down. So once you pick a number, doesn't mean you have to stick with it forever. You're not married to it. So I'm going to change this to 20. I'll make it 25 even. Like this 40. The point is, I want as good a data as possible where the set point changes. Garbage. Pegs at 100. This thing goes to 0. Actually, this thing going to 0 makes it. All right, so it's steadying down. When's it going to change?
Right about now.
20? 25. So it's steadying down. This is beautiful. Look! Look! Think that was overshoot? And a decay ratio. Hard to see. Now let me show you what the trick is. It's going to take a while, but let me show you the trick. I'm going to run an experiment. Then I'm going to back up and run the same experiment again so that when the second experiment starts, it will already have some water flowing in the system. Pressure doesn't have that problem. This is a problem unique to flow and maybe duct cooling.
start.
And right now, I'm waiting for the first experiment to finish.
So it starts nearly when the system's
Before this
already
one
at
starts.
steady
What?
state. It starts up when the system's nearly already at steady state anyway.
Yeah. Start us at a reasonable place rather than zero. You see how well behaved this is? Uh-huh. All right, that's what you get for the flow system.
It looks like a very image in each other.
All right, you see some overshoot there. The red line goes up above the final steady state value, and then it comes back down. Let's do another one that has a larger change in set point of 25 with that same gain. Might be easier to see the overshoot, and it ought to be the same phenomenon by and large. When the flow goes up, the controller says, oh, I don't need to have so much input. When the flow goes down, the controller said, oh, I need to increase the input. Flow goes up, the controller says, oh, I need to decrease the input. Steady operation. Look at this, isn't that beautiful? Change the set point and bing! Bing! Everybody's like, bing!
Bing.
There's a word for that.
Is it Bing?
Let me tell you what it is?
Is it Bing?
No, it's Google. No, it's actually two words. The first word is proportional. And the second word, let me give you a visual hint, is kick. That's called the proportional kick. The height of that, by the way, is equal to K times delta R. This is amazing.
Pretty sweet.
It might not be because this is pegged at 100. Look at that, overshoot and then settling down. So this looks like approximately quarter to K. Approximately. I just guessed it. Let's increase the proportional gain again to 4 and see what happens. 3, I mean. Okay, this is the last flow I'm going to do. By the way, the step that you asked for, I already showed you a step in the positive direction. Steps in the negative directions are equally useful for demonstration or for learning. What's the time on that, Ollie?
13 minutes and 30 seconds.
You know how to stop it and start again?
You just push the button.
Yeah. This is closer to quarter decay or between quarter decay